Hello, this is David Shreeve, Algebra 2 instructor with Florida Virtual School. We're going to be looking at finding some different values here with a couple of these quadratics. We're going to look at this over here. You see I've just written this is general form. We're going to put this in general form in a bit. But before we do that, we're going to go ahead and find a couple values here. When we have it in this format, it's not a lot we can do with it. We always want to get this into standard form first. So standard form looks like this: ax squared plus bx plus c equals 0 or equals y, or sometimes you'll see the function of x equals ax squared plus bx plus c. They list it several different ways. Now to find first the axis of symmetry here. By the way, I'm just subtracting 7 from each side to get this into standard form. We have a formula to find the equation of the axis of symmetry here, and it's negative b over 2a. When we say axis of symmetry, if I have a parabola, like something like that, the axis of symmetry is just the equation of the line that basically cuts that parabola right in half. So we're looking for the equation of this line. Now, with these parabolas, they're all going to be either a parabola with the ends going up or a parabola with the ends going down. So all of our equations for our axis of symmetry will be vertical lines, meaning they'll be x equals some numerical value. Now, all I'm going to do is identify my A, my B, and my C. We don't really need the C value here, but just out of habit, I always write all the values down. So A is 1, meaning the coefficient of the x squared term. B is negative 4, meaning the coefficient of the x term. And then C is negative 7, which is the constant over here. Like I said, we're not going to use the C value at this point, not for this particular purpose of what we're trying to find here, which is just the axis of symmetry. Be careful with your signs here, because my B value is a negative 4. And remember, you have the existing negative in the formula there, so we do have a negative 4 over 2a is 1, so 2 times 1. Alright. And then continuing, 2 times 1 is 2. Negative 4 divided by 2 is negative 2. But you have a negative 2, which means the opposite of negative 2. Or you could consider it a negative 1 times negative 2. Either way, it's x equals 2. That's our axis of symmetry. Alright, so when we're thinking of it on a coordinate plane, if I have my x and y axis here, here's an x value of 2. X equals 2 is just a line going through that point 2 on the x-axis. Alright. Now, sometimes we're asked not only to find the axis of symmetry, but to find the vertex. Now, when we find a vertex, we're talking about, if we're looking at this parabola, the vertex is this point right in the center. So you have a parabola sometimes pointing up, sometimes pointing down. The vertex is just right there. You might remember vertex as part of the vocabulary from your geometry course as well. Vertex in that case, we might say the vertex of an angle. It's just that point here. Or we might say the end of the V, or in this case the end of the U. So we need general form. General form is written here: y equals a times the quantity x minus h squared plus k. This is a little easier to find our vertex because the vertex is just h comma k. Now, if we look at our, and I'm going to use this since we've already got it in standard form. If we look at this, well, we can't really find an h and a k value here at all. So what we're going to have to do is called complete the square. When we complete the square, we'll be able to put this into general form. So if y equals x squared minus 4x minus 7, what you'll have to do first is replace your y with 0. I really would prefer my 0 to be on the right here. I'm just going to cross that out and move the equal to 0 over to the right. What we're going to do here first is get rid of this 7. We'll do that by simply adding a 7 to each side. So when I add 7 to each side, I'm left with x squared minus 4x equals 0 plus 7, which is 7. And you'll notice I left a little space right here, so we have specific steps we're going to do. One, I'm going to take the coefficient of my x term, and I'm going to cut it in half. So negative 4 times 1/2. Well, that equals negative 2. So my next step here is to take that negative 2 and square it. Well, that equals 4. Now I'm going to use this 4. I'm going to add it to each side of the equation. Remember, I can't add something to one side of the equal sign unless I also add it to the other side of the equal sign. I have to keep everything equivalent as I'm moving through this process. The reason we complete the square is we're creating a perfect square trinomial over here on the left-hand side. So we're going to factor that. That's just x minus 2 times x minus 2. I'm going to write that as x minus 2 squared equals 7 plus 4 is 11. Now this still doesn't look exactly like my general form up here. I need to say y equals and then have something not. This doesn't quite look like that. So we do need to get this 11 back over here. We can do that by subtracting the 11. That's going to leave us with x minus 2 squared minus 11. I could say equal to 0 or 0 equals, but in this case I want it to say y equals, just so it'll be exactly like my general form here. Now remember, our vertex is h comma k. H comma k. Well, in this case our h value you could see here is 2 and our k value is negative 11. So our vertex here is 2 comma negative 11. Now we can find the equation of the axis of symmetry when an equation is in general form simply by taking this binomial in the parentheses and setting it equal to 0 and solving for x. So x minus 2 equals 0. Add 2 to each side and x equals 2. You'll notice that obviously we end up with the same answer regardless of the method we use to find that value. Now that I know my axis of symmetry and my vertex, you also notice that the axis of symmetry, which is an equation, it's a linear equation, x equals some value, it's a vertical line, but it's always going to be the x value of your vertex. So that's another way to think of what is my axis of symmetry. Well, it's just the x value of the vertex. So we have several ways we can determine the axis of symmetry. Since I have the axis of symmetry and the vertex, you could make a quick sketch of that graph. It would look something like this. Alright, so x is 2, that's right here. I know that's my axis of symmetry. And then negative 11, let's say that negative 11 is way down here. So 2, negative 11 is the vertex. My a value is positive, so this parabola does open upward. So that graph looks something like that. Right, and that, like I said, that's just if we're making a quick sketch. This would not be valid for finding the x-intercepts or anything like that, but it would give us a chance to make a quick sketch of the graph. So, alright, I'm going to make an additional recording of finding the zeros, and we'll use this same example, and we'll find the zeros by completing the square and the quadratic formula based on the discriminant. So what we're going to do is we're going to find the discriminant, and then we'll solve it using quadratic formula, and then we'll solve it by completing the square. So look for that video coming up. I hope this helps.